how I am seeing all these beautiful objects? Well, the reason lies in chemistry. Our vision requires a protein called rhodopsin. Rhodopsin has a small helper molecule, cis-11 retinal, which is made from vitamin A. An important phenomenon occurs on cis-11 retinal because of which we can see the beautiful world around us. What is it? Let's find out in today's episode. Hello everybody, I am Devabrata Goswami and I warmly welcome you to the colorful world of chemistry. Today we will study a phenomenon that is found all around us and yet is so unique that it can help us see. Yes, I am talking about isomerism. In today's episode, we will study what isomerism is and the different types of isomerism, that is, structural isomerism and stereoisomerism. Finally, we will look at ways and means to crack your exams in exam Decoded. Let's start our journey today with isomerism. What is isomerism? Well, the word isomerism is derived from the Greek word isos, which means equal, and meros, which means part. So it refers to bilateral similarity, if not equivalence of structures. It was a term coined by Swedish scientist Johannes Jacob Berzelius. But what exactly does isomerism mean? Isomerism is the phenomenon of existence of two or more compounds having the same molecular formula but different properties. And compounds like these are called isomers. Isomerism can be broadly classified into two categories as structural isomerism and stereoisomerism. So, let's take structural isomerism first. Structural isomers are molecules which have the same molecular formula but different structures. Basically, the structural arrangement of their atoms is different, and this phenomenon is called structural isomerism. Structural isomerism is further classified into four types: chain isomerism, position isomerism, functional group isomerism, and metamerism. Let's start with chain isomerism. Let us take the example of butane. It is an alkane with 4 carbons and 10 hydrogens. Now, if I try and arrange the carbon and hydrogen atoms, two structural arrangements are possible. This first one has carbons arranged in a straight chain and has a name N-butane. The second one has 3 carbons arranged in a straight chain and 1 carbon as a branch on the second carbon. This is known as isobutane. Both these compounds have the same molecular formula C4H10, but different carbon skeletons. Such compounds are called chain isomers. The second type of structural isomerism is a position isomerism. In this type of isomerism, 2 or more compounds differ in the position of substituent atoms or functional groups on the carbon skeleton. The molecular formula remains the same. Such isomers have the same carbon skeleton. Let us take the example of bromopropane. We know that there are 3 carbon atoms in propane. Now, there are two positions of carbons on which the functional group, the bromo group, can attach, either on the first carbon or onto the second carbon. If bromo group is attached to the first carbon, it is called 1-bromopropane. And if bromo group is attached to the second carbon, it is called 2-bromopropane. So, we can say that there are two position isomers with the molecular formula C3H7Br. Now, the third type of structural isomerism is functional group isomerism. As the name suggests, in this type of isomerism, the isomers contain different functional groups, but remember, the molecular formula remains the same. For example, a compound with molecular formula C3H6O2 has two functional group isomers, propanoic acid, in which the functional group is a carboxylic acid, and methyl ethanoate, in which the functional group is an ester. The last type of structural isomerism that we will study is metamerism. Metamerism arises due to different alkyl chains on either side of the functional group in the molecule. Let's take an example to illustrate this. The compound with the molecular formula C4H11N shows metamerism. The first isomer has two ethyl groups on each side of NH. In the second isomer, there is a methyl group on one side and a propyl group on the other side of NH. Thus, metamerism arises due to different alkyl chain on either side of the functional group in the molecule. I think now it's time to take a break so that you can digest the different types of structural isomers. But before going, I want you to think about this question. What are the functional groups which show metamerism? You can search the answer on www.topperlearning.com or just wait for me to come back. Welcome back. This is Devabrata Goswami and you are watching Chemistry 11. Before the break, I had asked you what are the functional groups which show metamerism. I hope you tried to look up the answer, but anyways, here it is. Metamerism is shown by functional groups NH, O, S or C double bond O group. Let's move on. Now I want to introduce you to the other kind of isomerism, that is stereoisomerism. In stereoisomerism, the compounds have the same constitution and sequence of covalent bonds, which is unlike structural isomerism, but they differ in relative positions of their atoms or groups in space. Let's discuss it in detail. There are two types of stereoisomerism, namely geometrical isomerism and optical isomerism. Let's begin with geometrical isomerism. Geometrical isomerism arises because of different spatial arrangement of atoms. This happens because of the restricted rotation of the carbon-carbon double bond. But geometrical isomerism can also arise from ring structures where the rotation of bonds is greatly restricted. Molecules exhibiting geometrical isomerism are called geometrical isomers. Let's take the example of but2ene to understand geometrical isomerism. This molecule has a double bond between the second and third carbon. Due to this double bond, there will be restricted rotation in the molecule around the second and third carbon. And there will be two different arrangements of atoms or groups in space. When the two identical groups are present on the same side of the double bond, the isomer is referred to as a cis isomer. In but2-ene, the structure in which the two methyl groups are on the same side of the double bond is named as cis but2-ene. But what if the two methyl groups are present on the opposite sides of the double bond? Such a structure is referred to as trans but2-ene. So in general, when two identical groups are present on the opposite sides of the double bond, the isomer is referred to as trans isomer. Geometrical isomerism is also called as cis-trans isomerism. We have a caller with us. Let us clarify a doubt.
Hello sir, my name is Ishan. My question is, though alkyne have a triple bond, do they also show cis-trans isomerism?
Well, this is a nice question. The answer is no. Alkynes do not show cis-trans isomerism. I will tell you why. This is because alkynes have a triple bond, so alkynes are linear and there will be no restricted rotation, and different arrangement of substituents of atoms and groups in space is not possible. Remember that in the beginning of the show, we talked about cis11 retinal, which helps in vision. This is converted to trans-retinal when exposed to light. Therefore, the light energy is absorbed during the conversion of isomers of retinal. It is then given off to the protein and transported through the visual system to enable us to see. This shows how significant geometrical isomerism is. Let us now move on to optical isomerism. But before that, we must know what optical activity is. We know that light is made up of electromagnetic waves vibrating in all directions. Such a light is called a non-polarized light or unpolarized light. When this unpolarized light is passed through Nicol prism, we get plane polarized light. Plane polarized light is defined as the light which oscillates in only one plane. There are certain substances which rotate the plane polarized light. Such substances are called optically active substances. When a substance rotates the plane of polarized light in the clockwise direction, it is named dextrorotatory or the plus form, and when a substance rotates the plane of polarized light in anti-clockwise direction, it is called levorotatory or the minus form. Well, that's all for today. Now it's time for a short break. But stay tuned, because coming up after the break is the segment which will show you how to put all this knowledge to good use. Yes, I'll be back with Exam Decoded after this break. But as you know, chemistry fundas are just a click away. I mean, you can always log on to www.topperlearning.com for more practice and more examples. I will leave you with a question. Who discovered and developed the first prism that produced plane polarized light? Welcome back to chemistry. I am Devabrata Goswami, and today we are talking about isomerism. Before the break, I had asked you who discovered and developed the first prism that produced plane polarized light. Well, the answer is William Nicol. He developed the first prism that produced plane polarized light. And now it's time to test your knowledge. But before we do that, let's do a quick recap of all that we have learned today. In this episode, we studied the phenomenon of isomerism. To define it, the existence of two or more compounds with the same molecular formula but different properties is known as isomerism. The phenomenon in which molecules have same molecular formula but different structural arrangements of the atoms is called structural isomerism. The phenomenon in which compounds have the same constitution and sequence of covalent bonds but differ in relative positions of their atoms or groups in space is called stereoisomerism. Now that we have refreshed our learnings, let's go on to exam Decoded. Welcome to exam Decoded. Before I give you some important tips on today's episode, let's play our usual rapid fire round. The rules are the same as always. I will ask you 5 questions and you must answer each question in less than 5 seconds. You will get 1 mark for each correct answer and I will help you interpret your total with our special topper scorecard. So let's begin. Here is your first question. Cis-trans isomerism is also called A. Optical isomerism, B. Functional isomerism, C. Positional isomerism, D. Geometrical isomerism. The answer is D. Cis-trans isomerism is also called geometrical isomerism. Question 2. N-butane and isobutane are which kind of isomers? A. Geometrical, B. Metamers, C. Chain, D. Position. The answer is C. They are chain isomers as N-butane is straight chain and isobutane is branched. The third question. The isomers in which the two identical groups are present on the same side of the double bond are A. Chain isomers, B. Position isomers, C. Trans isomer, D. Cis isomer. The answer is D. Cis isomer. Second last question. Metabolism arises due to different alkyl chains on either side of the functional group in the molecule. True or false? Well, the answer is true. And now the last. 1 bromopropane and 2 bromopropane are chain isomers. True or false? Well, the answer is false. They are position isomers. And now for the scores. Compare your total with our scorecard and see where you fit. If you have scored full marks, then you are a high flyer and can rest assured that your preparation is going well. If you have scored 4 or 3, then you are an achiever. You need just a bit more revision of sample questions. If you have scored less than 3, then you need help with the basic concepts of this topic. You can get this help on www.topperlearning.com. Moving on, let's take a look at the latest exam trends. Today's topic comes under the unit Organic Chemistry, Basic Principles and Techniques. It has a weightage of 7 marks, which makes it a critical unit to focus on. The questions asked from this topic can be very short answer type questions for 1 mark and short answer type questions for 2 or 3 marks. These questions pertain to knowledge ability. Here is a 2-mark question to brush up your concepts about this topic. Identify the type of isomerism that exists between the given molecules. Take a look at the first set of molecules on your screen. You can see that both structures have the same molecular formula C5H10O. The first structure represents a ketone, namely 3-pentanone, and the second structure represents an aldehyde, that is 1-pentanal. Since these two isomers have different functional groups, they exhibit functional group isomerism. This information will fetch you 1 mark. Now for the second part. You can see that the two structures have the same molecular formula. Now, the next step is to identify the type of isomerism. The two given structures have the same functional group, that is ether, but they have different alkyl chains on either side of the functional group in the molecule. So, these two isomers are metamers and exhibit metamerism. This will fetch you the remaining mark. Well, it's time to say goodbye, but I will leave you with some food for thought. How can the concept of optical rotation be used to measure sugar concentration in sugar industry? Confused? Don't be. Just keep thinking and you will come up with the answer. For more help, you can always log on to www.topperlearning.com. Till then, it's Devabrato wishing you a well-structured preparation.